Okay, this is a video to talk about working with all the exponent properties. It's meant to help review what you learned in class. The slogan we're going to be working with is every day math adds something new. This is very similar to please excuse my dear Aunt Sally that you guys may have learned in middle school when talking about properties of order of operations. Please excuse my dear Aunt Sally. So we're going to use our new version, every day math adds something new, to give you the letters to work through properties of exponents problems. It's meant to just be a reminder. E stands for exponents, give every factor an exponent. D, distribute outer exponents to inner exponents. M is move negative exponents top to bottom. A, add across the exponents of like bases. S, subtract the smaller exponents from the larger. N, numbers, deal with them. This is a way to work through all the properties of exponents instead of taking each one separately and then trying to figure out which one to do first. This is just a possible order that you could do. And we've talked about properties of exponents in class and why they work. Feel free to ask your teacher why they work if you still don't understand. So I'm going to use this on a smaller scale on each page. I have a number of slides, so this video might take 15-20 minutes, but you can skip around and do what you want to do. I know you may not watch the whole thing. Okay, so every day math adds something new. E stands for exponents. Give every factor an exponent. So I have a factor of 2 and a factor of x and a factor of 3 that don't have exponents, so I put the ones there. That's really just to help save you time later, because the exponent tells you how many factors there are. There's one factor of 2, one factor of x. There's already 2 factors of y. That's what the y squared means. So we put the ones there. D is distribute outer exponents to inner exponents. This is talking about when you have a parentheses squared. I don't have a parentheses squared, so I can skip that step. M, move negative exponents top to bottom of the fraction. I don't have any negative exponents. A, everyday math adds something new. A, add across exponents of like bases. So I have a 2 to the first power, and I have a 3 to the first power. Those aren't the same base, so I'm not adding any exponents. I do have an x to the first power and an x to the third. So my base is x, and my exponent is 1 plus 3. There's 4 factors of x. 1 factor of x times 3 factors of x pardon me, gives me 4 factors of x. For the y's, y squared times y to the 4th means that you have 6 factors of x being 6 factors of y being multiplied together. So that's y to the 6th, sorry. Y to the 6th. So I've dealt with the move, I've dealt with the add across. I don't have a fraction. This is talking about fractions. When we're subtracting the smaller exponent from the larger, that's using a division problem when you have a fraction. So that's dealt with already. And then numbers, deal with the numbers normally. So 2 times 3. 2 times 3, 2 to the first is 2, 3 to the first is 3, so that's 6. So my final answer is 6x to the 4th, y to the 6th. I'm going to go on to the next example and go through that same process. Every day math adds something new. So I know we're kind of at the 4-minute mark already. Again, this is going to be a longer video showing lots of examples. You can pause and try some problems and then try some more. Okay, every day math adds something new. Every, the E stands for exponents. Give every factor an exponent, so the 3 needs one. Done. Every day, the D stands for distribute. Distribute outer exponents to inner exponents. So this 5 gets multiplied by every exponent, because as an exponent, something to the 5th power means that it's there 5 times. Means that there are 5 factors of n being multiplied. So if I have 3 to the first, then it means there's 5 3s. being multiplied. X to the fourth is being multiplied 5 times, etc. That's what's going on in that problem. So if I distribute my exponents, I'm going to rewrite this as 3xy. My 3 is to the 5th because of 1 times 5. My x is to the 20 because of 4 times 5. My y is to the 10th because of 2 times 5. Everyday math, move negative exponents. I don't have any. A, add. Everyday math adds something new. Add exponents across like bases. There are no like bases. I have a 3, an x, and a y. Subtract, smaller exponent from larger. That's with fractions. I don't have fractions. And deal with the numbers. So 3 to the 5th, you can use your calculator. 3 to the 5th is 243. So my answer is going to be 243, x to the 20th, y to the 10th. Feel free to pause there, rewind if you need to. We are at the 6-minute mark now. We can go on to another example. Okay, this time I have a fraction, so we'll start to see some of our other things. Every day, math adds something new. Every, E goes with exponents. Every factor, 5 should have an exponent. Y should have an exponent. 20 should have an exponent. D, distribute outer exponents to inner exponents. That's when I have a parentheses with an exponent. I don't have any parentheses, so that's done. Move negative exponents top to bottom. I don't have any negative exponents. Add across exponents like bases. Everyday math adds something new. So on top, I just have a 5, an x, and a y. So there's no same bases on top of the fraction. There's no exponents that need to be added. On the bottom, I have a base of 20, a base of x, a base of y. There are no like bases, so there are no exponents that need to be added. Subtract smaller exponent from the larger. So we're going to do that now. My 5 over 20 is just going to stay 5 over 20 because those are numbers. Those are just different bases. Those aren't exponents. They each have an exponent of 1. My x to the third, x to the second is going to be x to the 3 minus 2. Subtract the smaller one, 2, from the larger one. 3 minus 2 is 1, so there's an x to the 1. The x is on top of the fraction because there's a larger number of factors of x on top. So 3 minus 2 is 1. The y's, 6 minus 1 is 5. Because there's y to the 6th on bottom, there are more factors of y on bottom. So my final answer has y to the 5th on bottom. You can talk to your teacher about the reason why that works if you'd like to see a different explanation for that working out. So subtract smaller exponent from the larger. We did that. And then n, numbers, deal with them normally. So 5 to the first is just 5. 20 to the first is just 20. 5 divided by 20 as a fraction is 1/4. So my final answer is 1 x to the 1 over 4 y to the 5th. And you could just write that as x over 4 y to the 5th. Feel free to pause here, do a couple practice problems, rewind it back to the 6-minute mark if you want to see this again. We're at minute number 9 right now. I think I have a couple more examples to do. Okay, same thing. We're going to go through the same process. Every day, math adds something new. Every is exponents. Make sure every factor has an exponent. This is where students, if you don't do this step because you don't see any value in this step, this is where students start to make mistakes. When you have to do step 2, students forget to distribute the outer exponent if they don't do that every factor gets an exponent first. So every factor has an exponent. Distribute. We're going to take this 2 and multiply every exponent on top, every exponent on bottom. So that's 6 things. So if I rewrite my fraction with all the bases, 3ab on top, 4ab on bottom. I'm going to use the pink marker and show the distributing. 2 times 1. Let me erase that first, make it more obvious. So this outer exponent 2 distributed to the 1. 2 times 1 is 2, so there's a 3 squared. Distributed to the 4. 2 times 4 is 8, a to the 8th. 2 times 2 is 4, b to the 4th. 2 times the 1 on the bottom is 2, 4 squared. 2 times the 3 on the bottom is 6, a to the 6th. 2 times 1 on the bottom is 2, b squared. So I've now distributed outer exponents to inner exponents. Move negative exponents, still don't have any negative exponents, that's done. Everyday math adds something new. Add exponents of like bases, so there's nothing on top. There are no factors with the same base. We have a factor of 3, a factor of a, and a factor of b. There's no same bases. On the bottom we have a factor of 4, a factor of a factor of b. No same bases, so that's done. Everyday math adds something. S is for subtract. Subtract the smaller exponent from the larger. That's when you're dealing with fractions. My 3 squared stays what it is. My 4 squared stays what it is. Those aren't the same base, so we don't mess with their exponents. We leave them alone. For the a values, those are the same base. A to the 8th over a to the 6th. If I have 8 factors of a, 1, 2, 3, 4, 5, 6, 7, 8, divided by 6 factors of a, 1, 2, 3, 4, 5, 6. Every time you have a single factor divided by itself, it gives you a 1. So a divided by a is 1. We can do that a number of times. There's 4 ones, 5 ones, 6 ones. 1 times 1 times 1 times 1 times 1 times 1 times a is a squared. Subtract 8 minus 6 is a squared. Last one, b to the 4th over b squared. 4 minus 2 is 2, so b squared. Everyday math adds something new. N, numbers, deal with numbers normally. So 3 squared is 9. 4 squared is 16. 9 divided by 16 is already simplified. That's your final answer. So at minute number 13. If you want to rewind and watch this example again, it starts at minute number 9. Otherwise, we're going to go on to the next example. I think we have 2 left. Okay. Same thing, 2 more examples. Told you this video would be a little bit long. You don't have to watch the whole thing. Everyday math adds something new. E, give every exponent, every factor an exponent. The 2 gets an exponent, the 6 gets an exponent. Distribute outer exponents to inner exponents. That's if I have a parentheses. I don't have a parentheses, so I'm done. Move negative exponents from top to bottom. So this a to the negative 3 is going to come to the bottom. That means my fraction is going to look like this. 2 to the 1st, b to the 0, 6 to the 1st, a to the 5th, and now I have a to the positive 3, and I have a b squared. For more information on why the negative exponent can move from top to bottom, why it becomes a positive exponent when it moves from top to bottom or bottom to top, please ask your math teacher. This is more about the process, and in class you guys will talk about why that works, but mathematically they are the same thing. That's done. A is add across. So on top of my fraction, I have 2 to the 1st times b to the 0. On the bottom, I have 6 to the 1st. I have these 2 that are multiplied, same bases. Add across the exponents of like bases. So a to the 5th, a to the 3rd is a to the 5 plus 3. I also have a b squared. So that step's done. Subtract smaller exponent from larger. Again, same bases. So if I have the same bases, everyday math adds something new. Something s subtract. So 0 minus 2 is 2. So this would be 2 to the first over 6 to the first, a to the eighth. 2 minus 0 is 2. You could say that the b to the 0 didn't really do anything because we had a b squared already and we still have a b squared. That's because, on a little side note in orange, when you take a number besides 0 and you raise it to the 0 power, it's equal to 1. So b to the 0 equals 1. So that's why the b squared on bottom really just stayed a b squared. And then n is to deal with your numbers. So deal with your numbers. I have a 2 over a 6. I also have the a to the eighth b squared. 2 over 6 is 1 over 3. So 1 over 3 a to the eighth b squared. Okay, we started that at the 13-minute mark. It's now 16:25 where we finished that one. We have one more example to go through. I said it would be about 20 minutes maybe for this whole video series to go through multiple examples. This last one is, about as big as we're going to make these problems get. It doesn't matter the size of the problem. You still treat every problem using the same order if you want to do the problems. You could change things up, but this order works. It gives every answer, if we look back through, gives every answer with a single letter, A and B, not two A's and two B's. It gives no negative exponents. So I don't have any negative exponents. I don't have any zero exponents. So this process puts your answer into a final form. So this one will take a little bit of time. Still do every step. Exponents, give every factor an exponent. There's a 1 on the 2, a 1 on the x, a 1 exponent on the 3, a 1 on the 4, a 1 on the 6, a 1 on the x. Done. Distribute outer exponents to inner exponents. The only time that's going to take place is right here. In pink, I have to do -1 times all those things. So if I rewrote this step, I'd have 2x and y. 2 would be to the -1. X would be to the -1. Y would be to the -3. Everything else is staying the same. 4 to the 1, x squared, y to the -4, times 3 to the 1, x squared, y to the 5th, over 6 to the 1, x to the 1, y to the -2. We just did one step. I had to write stuff down, but if I do one step, it's easier to follow the order. Everyday math. Add something new. Math, M, means move. Any negative exponents get moved. So 2 to the -1 goes to the bottom of the fraction. X to the -1 goes to the bottom of the fraction. Y to the -3 goes to the bottom of the fraction. Y to the -4 is in the bottom, goes to the top. Y to the -2 is in the bottom, it goes to the top. We know that something like 2 to the -3 is equal to 0.125. You can use your calculator and check that. I know that 1 divided by 2 to the +3 is also 0.125. It is a mathematical property that a negative exponent can be moved to get the same answer. I could also show that the other direction. If I have a 3 to the -2 on bottom, in my calculator, that's going to equal 9. If I take 3 to the +2 without a fraction, I also get 9. So this property of I can rewrite a factor with a positive exponent by switching it from the numerator to the denominator, or from the denominator to the numerator, is a valid mathematical step. So I'm going to rewrite this mess. In my first fraction, I'm going to highlight anything that moved in green. The 2 to the negative 1 became a 2 to the positive 1 on bottom. The x to the negative 1 became an x to the positive 1 on bottom. The y to the negative 3 became a y to the positive 3 on bottom, or in the denominator. On bottom, I already had a 4 to the first power and an x squared. I'm going to rewrite those in black because they didn't move. They were already there. So here's my 4 and my x squared. The y to the negative 4 was on bottom. It goes to the top as a positive 4. On the second fraction, the top is similar. So 3 to the first, x squared, y to the fifth. But something else is moving. That y to the negative 2 becomes a y to the positive 2 on top. On bottom, I had a 6 to the 1 and an x to the 1. So that step took a while, but we've moved all the negative exponents. Now we're adding across exponents of like bases. This multiplication sign in the middle tells me that I'm actually multiplying two fractions. When you multiply two fractions, you multiply across the top, or the numerator, and you multiply all the factors on the bottom, or the denominator. So I'm going to multiply across the y to the fourth, y to the square, y to the fifth is going to give me 4 plus 5 plus 2, which is 11. So y to the 11th. I already have a 3 there and an x squared. On the bottom, I have a 4 and a 6 being multiplied, and a 2. I also have an x to the first, x to the squared, x to the first. So 1 plus 2 plus 1 is x to the fourth. And I have a y to the third. So everyday math adds. We just added across. Now we're going to subtract smaller exponents from larger. So right here with the x, same base. That's going to give me an x squared on bottom, because 4 minus 2 is 2. There's more factors on bottom, so it goes on bottom. The y values, same base. 11 minus 3 is 8. Give me a y value of 8 on top, because there's 11 factors on top. And then I still have a 3 to the first, so a 3, and a 2 times 4 times 6 on bottom. My last step is to deal with the numbers. Everyday math adds something new. So for my numbers, I have 3y to the 8th over 2 times 4 times 6 is 8 times 6 is 48 x squared. 3 divided by 48 is 1 over 16. 1 y to the 8th over 16 x squared, or y to the 8th over 16 x squared. So yes, that problem did take a while. I think we started at the 16-minute mark. But if you follow each of the steps, it takes a while, but it is a very doable problem. So if you want to rewatch that, go back to the 16-minute mark and you'll have it. Those are my examples. Sorry it's a long video, but lots of examples that you can pause and watch when you need to. Thanks.